Imagine the moment, not as allegory, not as theology, but as physics. The year is approximately 1650 BCE. The Jordan Valley lies in the afternoon light, the Dead Sea glittering to the south, the green fields of what Genesis calls the Kikar, the disk or plain, stretching northward from the sea, across one of the most fertile and most densely settled landscapes in the ancient Near East. The city is enormous by the standards of its time, a metropolis of perhaps 50,000 people, with walls, with towers, with palaces and temples and markets, and the dense, complex social life of a major Bronze Age urban center. The potters are firing their clay. The traders are arguing over prices. The children are playing in the streets. And then something appears in the sky. It does not look like much at first. A point of light, perhaps, moving faster than any bird, faster than any experience has taught the people below to expect anything to move. But within seconds, the point of light becomes a fireball, and the fireball becomes something that fills the sky, and the air itself begins to behave in ways that no living person has seen before, heated by the passage of an object moving through the atmosphere at tens of kilometers per second, compressed ahead of it into a wave of pressure that arrives at the ground as a shock wave of extraordinary violence. The fireball detonates, not on the ground, in the air, a few kilometers above the city, at the altitude where the object's kinetic energy, the energy of its motion, exceeds the structural integrity of its own material, and it comes apart in an explosion that releases, in a fraction of a second, energy equivalent to approximately 1,000 Hiroshima atomic bombs. The temperature at the center of the detonation exceeds the surface of the sun, 30,000 Kelvin perhaps in the initial fireball. The surface of the sun is approximately 5,778 Kelvin. The object above the Jordan Valley is approximately 5 times hotter than the star at the center of the solar system, and for a fraction of a second, it makes that heat available to everything below it. The city dies in seconds. The mud brick walls melt. The pottery in the streets and the houses and the workshops does not merely shatter from the shock wave. It melts. The outer surfaces of the ceramic, the fired clay that the potters worked at temperatures of perhaps 900 degrees Celsius, liquefy at the surface because the temperature of the event is sufficient to melt not just the clay, but the minerals from which the clay is made, at temperatures exceeding 4,000 degrees Celsius, which is twice the temperature of any furnace the Bronze Age world possessed, and roughly equal to the temperature of the outer atmosphere of the sun. 50,000 people are gone in the time it takes to fall. The city is not burned, it is not conquered, it is obliterated by a heat source from the sky that the people below had no concept of and no preparation for. This is what the evidence says. This is what 21 researchers from 17 institutions, led by Christopher Moore of the University of South Carolina, concluded in a paper published in September 2021 in the journal Scientific Reports, a journal of the Nature Publishing Group. Their paper, titled "A Tunguska-Sized Airburst Destroyed Tol el-Hammam, a Middle Bronze Age City in the Jordan Valley, near the Dead Sea," is one of the most extraordinary papers published in archaeology in the 21st century, not because it is speculative, but because it is rigorous, because it assembles evidence from geology, geochemistry, material science, and archaeology into a coherent picture of a real event that destroyed a real city and that may have been remembered in the oral tradition of a specific people for 3,500 years. The site is called Tol el-Hammam. It sits on the northeastern shore of the Dead Sea, in what is now the modern country of Jordan, in the southernmost section of the Jordan Valley, approximately 14 kilometers northeast of the ancient city of Jericho, and approximately 5 kilometers east of the Jordan River. It is a tel, an Arabic word for a mound, formed by the accumulated debris of successive occupation layers. The dead cities buried one on top of another, as each generation builds on the ruins of the previous one. Tall el-Hammam is a large tell, even by the standards of the ancient Near East, where tells can be significant features of the landscape, rising 10 or 20 meters above the surrounding plain. Archaeological survey has confirmed that it was, in the Middle Bronze Age, one of the largest cities in the region, with an occupied area of approximately 100 acres and the population that an urban center of that size would have supported. The Jordan Valley in the Bronze Age was, by the testimony of multiple ancient sources and by the archaeological evidence of the sites distributed across it, a densely populated and agriculturally productive landscape. The valley runs north-south, bounded by the hills of Judea and Samaria to the west and the highlands of Jordan to the east, and it carries the Jordan River from the Sea of Galilee in the north to the Dead Sea in the south. The Jordan River Valley is one of the lowest places on the surface of the earth, the Dead Sea sitting at approximately 430 meters below sea level, and the specific combination of valley depth, reliable water from the river, and the thermal advantages of a below-sea level landscape created agricultural conditions that supported dense human settlement from very early in the history of the region. By the Middle Bronze Age, the period that encompasses approximately 2000 to 1550 BCE, the southern Jordan Valley near the Dead Sea was home to a constellation of urban centers connected by trade routes and sharing the economic benefits of the fertile Kikar, the circular plain that Genesis describes in terms of extraordinary agricultural abundance. Tal el-Hammam dominated this landscape, larger than its neighbors, more fortified, more strategically situated on a ridge that provided both defensive advantage and visibility across the surrounding territory. The city had been occupied for approximately 2,500 years before its destruction. The earliest occupation dates to the Chalcolithic period, before the full development of Bronze Age civilization, and it continued through the early and intermediate Bronze Ages, before reaching its maximum size and sophistication in the Middle Bronze Age, the period of its destruction. 2,500 years of continuous habitation is enough time for a city to accumulate a substantial physical presence. Successive generations of construction built up the tell meter by meter, each level of habitation preserved beneath the level above it, a physical record of the city's history encoded in the stratigraphy. The archaeologists who work at Tal el-Hammam have been excavating it systematically since 2005 under the direction initially of Stephen Collins of Trinity Southwest University and later involving a growing international team. What they found as they worked down through the accumulated layers of occupation was a pattern that is familiar from any long-occupied Bronze Age site: the physical remains of houses, streets, public buildings, fortifications, pottery, metal objects, organic remains, and all the other material evidence of the daily life and the death and the long continuity of a functioning city. And then, at a specific level in the stratigraphic sequence, they found something different. And the destruction layer at Tal el-Hammam is approximately 1.5 meters thick. That is roughly 5 feet, a substantial deposit of debris that represents not the gradual accumulation of abandoned structures or the slow dissolution of mudbrick walls over years of disuse, but a rapid, catastrophic event that deposited enormous quantities of material in what the evidence suggests was a very short period. Within this layer, archaeologists found a range of materials that did not match any known pattern of ancient destruction by fire, earthquake, or military conquest. What they found was, and the researchers use this word with the precision of scientific description rather than hyperbole, anomalous. The pottery. In any Bronze Age destruction, fire produces a specific range of effects on ceramic materials. Pottery that was fired in an ancient kiln at temperatures between 800 and 1100 degrees Celsius, which is the range of ancient ceramic firing, has already undergone the transformations that heat produces in clay, the conversion of the clay minerals, the development of the specific hardness and color and texture that distinguish fired from unfired clay. Fire from the burning of a building, reaching temperatures of perhaps 600 to 800 degrees Celsius in an enclosed space, will smoke and stain the pottery, but will not fundamentally alter its structure, because the pottery has already been fired at higher temperatures. The pottery from the tall el-Hammam destruction layer was melted on its outer surface. The exterior surfaces of ceramic vessels in the destruction layer show evidence of temperatures that should not be achievable in any accidental or deliberate fire of the Bronze Age period. The clay minerals of the surface have been converted to glass, a process called sintering or vitrification, which requires temperatures far in excess of what any ancient kiln or fire could produce. The researchers who analyzed the pottery concluded that the exterior surfaces had been exposed to temperatures in excess of 2000 degrees Celsius, and that this heating was extremely brief, consistent with a sudden exposure to an intense heat source rather than with prolonged heating in a kiln or fire. The directionality of the melting is significant. The outer surfaces of the pottery were melted, not the inner surfaces. This is precisely the pattern you would expect from an external heat source that flooded the landscape with thermal radiation for a brief period. Everything exposed to the radiation would heat rapidly from the outside, while the interior, shielded by the mass of the object itself, would be heated much less. A fire inside a building would heat pottery from the inside out, or uniformly if the fire surrounded the object. The thermal radiation from an airburst would heat it from the outside in, exactly the pattern that the researchers observed. The mudbricks are even more dramatic evidence. Mudbrick, the fundamental construction material of the ancient Near East, is exactly what it sounds like. Brick made from mud, shaped and dried in the sun, rather than fired in a kiln. It is a strong, durable material that has kept standing for thousands of years in the arid climate of the Jordan Valley, provided it is not exposed to water for extended periods. It is not, under any ordinary circumstances, a material that melts. Converting mud into glass requires temperatures comparable to those of industrial glass manufacture, exceeding 1200 to 1500 degrees Celsius, and maintaining those temperatures for a sufficient period to allow the full conversion of the clay minerals to amorphous silica. The mudbricks from the destruction layer at Tal el-Hammam were vitrified, not softened, not charred, not simply damaged by heat, converted to glass. The researchers examined fragments of the mudbrick that retained their original shape but had been transformed at the material level, their crystalline mineral structure replaced by the disordered, amorphous structure of glass. This transformation requires not just very high temperatures, but a very specific pattern of heating, brief, intense, and from the outside. The interior of the mudbrick was not uniformly glassified. The transformation was concentrated on the surfaces exposed to the heat source and diminished with depth into the brick, exactly the pattern of thermal radiation from an external, brief, intense source. The temperatures required to achieve even partial vitrification of mudbrick are far beyond anything that Bronze Age technology could have produced deliberately, let alone accidentally. The most energetic fires, achievable with ancient fuel sources, including the controlled combustion of wood or animal materials in enclosed spaces, peak at temperatures of perhaps 1100 to 1200 degrees Celsius under ideal conditions. The vitrification of mudbrick that the researchers observed at Tal el-Hammam required temperatures that the researchers estimated at 4000 degrees Celsius or higher for the most completely transformed samples. No Bronze Age technology could have done this. No combination of ancient fuels and ancient furnace design could have approached this temperature. Something else was responsible. The high-pressure silica spherules provide the most direct connection to cosmic impact science. When a body of rock or ice or metal moving at very high velocity encounters the Earth's atmosphere, the extreme heat and pressure of the interaction can melt and vaporize portions of both the impacting body and the atmospheric material it compresses. Droplets of this molten material can solidify rapidly as they cool, forming tiny spherical particles that are called spherules or microspherules. These particles are distinctive markers of high-energy impact or airburst events, and are found at known impact and airburst sites around the world, from the Chicxulub crater in Mexico to the sites associated with the Younger Dryas impact event to the Tunguska airburst region in Siberia. The researchers found spherules in the destruction layer at Tol el-Hammam, 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 spherules in the destruction layer at Tol el-Hammam. The silica spherules are not unique finds in the destruction layer. They are found in quantity, distributed throughout the layer in a pattern consistent with their deposition from a single catastrophic event, rather than gradual accumulation or volcanic origin. The elemental anomalies in the destruction layer provide another line of evidence, pointing toward an extraterrestrial source for the destruction event. Iridium and platinum are elements that are rare in the Earth's crust, but that are present in significantly higher concentrations in some types of meteorites and in the material from extraterrestrial impacts. The famous Cretaceous-Paleogene boundary layer, the clay layer that marks the mass extinction event 66 million years ago that ended the age of the dinosaurs, was first identified as evidence of an extraterrestrial impact, partly because of its anomalously high concentrations of iridium, an element so rare in Earth's surface rocks that its presence at elevated levels essentially requires an extraterrestrial source. The researchers found elevated concentrations of platinum and iridium in the Tol el-Hammam destruction layer, not at the levels found at the Cretaceous-Paleogene boundary, which represents the debris of an asteroid estimated at 10 to 15 kilometers in diameter, but at levels significantly above the background concentrations in the surrounding sediments, consistent with the material from a much smaller extraterrestrial body, of the scale required to produce an airburst comparable to the Tunguska event. The shocked quartz is perhaps the most technically demanding element of the evidence. Quartz, silicon dioxide in its crystalline form, is one of the most common minerals on Earth and one of the most stable. It takes enormous pressure, on the order of several gigapascals, to permanently deform the crystal structure of quartz into the characteristic planar deformation features that geologists call shocked quartz. The conditions required to produce shocked quartz are, on Earth, found only in three contexts: at meteorite impact craters, at nuclear weapon detonation sites, and associated with the Younger Dryas cosmic impact event. The pressures involved are far beyond anything achievable by any tectonic or volcanic process, far beyond any explosives or fires available to human technology at any point in history, and far beyond any geological process other than those that involve the delivery of kinetic energy from a large, fast-moving extraterrestrial body. The researchers found shocked quartz in the destruction layer at Tol el-Hammam. The presence of shocked quartz in a relatively thin layer, not in a formed crater, but distributed across the destruction horizon of an archaeological site, is precisely what you would expect from an airburst event. An explosion in the atmosphere that delivers intense pressure to a relatively small geographic area without creating the impact structure of a direct ground strike. And then there is the salt. The Jordan Valley, and particularly the Dead Sea region, is one of the saltiest landscapes on Earth. The Dead Sea, which is not a sea in the oceanographic sense, but an endorheic lake, a lake with no outflow, into which the Jordan River flows, and from which evaporation extracts the water while leaving the dissolved minerals behind, has a salt concentration approximately 10 times that of the ocean. The surrounding landscape has been saturated with salt for millennia, and the soils of the valley carry this legacy in their mineral composition. A major airburst or shockwave event in this landscape would interact with this salt in specific ways. The shockwave from an airburst travels outward from the detonation point at supersonic speeds, compressing and displacing the air and everything in it. At the Dead Sea surface, the shockwave would create a spray, an aerosol of heavily salted water that would be deposited as the wave passed over the surrounding landscape. The researchers found a distinctive layer of salt above the destruction layer at Tall el-Hammam, consistent with exactly this mechanism. The salt deposit is significant beyond its mineralogical interest because it connects directly to one of the most distinctive details of the biblical account. The narrative of Sodom and Gomorrah in Genesis does not merely describe the city's destruction. It describes the aftermath as a landscape transformed, rendered barren, and it describes Lot's wife as having been turned into a pillar of salt when she looked back at the destruction. Whether this is understood as a literal description of a woman mineralized, a metaphorical expression of her fate, or a symbolic warning about looking back at what has been left behind, the association of the destruction with salt is specific and consistent with the salt deposit that the archaeological evidence reveals. The salt in the soil around Tall el-Hammam would have made agriculture difficult or impossible for years after the destruction event. Agricultural soils depend on a specific balance of minerals and organic matter, and the addition of large quantities of salt can create conditions hostile to plant growth, a phenomenon called soil salinization that affects agricultural productivity across much of the world today. A sudden deposit of salt from an airburst shockwave over the Jordan Valley would not merely have destroyed the city. It would have rendered the surrounding agricultural land unproductive for years, compounding the catastrophe and ensuring that whatever survivors there were could not simply remain in place and rebuild. The researchers reconstructed the parameters of the event from the physical evidence, using the known physics of airburst events and the measured temperatures and pressures indicated by the material evidence. Their reconstruction suggests an event comparable in energy to the Tunguska airburst of 1908, which is the largest impact event in recorded human history and is itself estimated to have released energy equivalent to between 10 and 15 megatons of TNT, or roughly 700 to 1,000 Hiroshima atomic bombs. The object responsible for Tunguska was a stony asteroid or a dense comet fragment estimated at perhaps 50 to 80 meters in diameter. The object responsible for the destruction of Tall el-Hammam, if the researchers' estimates are correct, was of comparable size. The Tunguska event occurred over an uninhabited forest in Siberia. The trees were flattened across an area of approximately 2,150 square kilometers. Had Tunguska occurred over a major population center, it would have been an unparalleled catastrophe. Estimates of what it would have done to a city the size of London or Paris suggest near total destruction across an area of dozens of square kilometers, with fire and shockwave damage extending much further. The population within the direct destruction radius would have had essentially no chance of survival. The object that struck the Jordan Valley struck, if the reconstruction is correct, one of the most densely populated areas of the Bronze Age Levant. The destruction at Tall el-Hammam was complete. the researchers found no evidence of rebuilding on top of the destruction layer, no evidence that the inhabitants returned to clear the debris and construct new buildings. Instead, after the destruction layer comes a period of abandonment, a gap in the archaeological record representing perhaps 300 to 600 years, during which the site was empty, or nearly so, the great city silent, the tell occupied only by the wind and the accumulated sediment. This pattern of abandonment, complete and prolonged, matches one of the most striking details of the biblical narrative. The destruction of Sodom and Gomorrah is not described as a temporary setback from which the cities eventually recover. It is presented as permanent, absolute, final. The cities are gone. The kikar, the fertile plain, is rendered dead. And indeed, when Tal el-Hammam was eventually reoccupied, it was as a much smaller settlement, without the elaborate fortifications and the urban sophistication of the Middle Bronze Age city. The metropolis that had dominated the southern Jordan Valley for 2,500 years was never rebuilt to its previous scale. The identification of Tal el-Hammam with Sodom, the specific biblical city, is the most contested aspect of the researchers' work, and they are appropriately careful about it. Archaeological identification of biblical sites is a fraught enterprise, complicated by the uncertain accuracy of ancient geographic descriptions, the imprecision of ancient dating relative to archaeological stratigraphy, and the intense religious and cultural stakes that attach to such identifications. The researchers present the connection not as an established fact, but as a strong possibility, arguing that the geographic, chronological, and physical correspondence between what they found at Tal el-Hammam and what the Genesis narrative describes is sufficiently close to warrant serious consideration. The geographic argument is the most straightforward. The Genesis narrative places the cities of the plain, of which Sodom is the most prominent, in the Kikar of the Jordan, the circular plain near the lower Jordan River and the Dead Sea. The Hebrew word kikar, which has the root meaning of a round loaf or disk, is applied consistently in Genesis to a specific geographic region that the narrative makes clear is visible from the hills near Bethel, north of Jerusalem, and that contains multiple cities within it. Tal el-Hammam sits within what most scholars identify as the Kikar, the southern Jordan Valley north of the Dead Sea, in exactly the location that the geographic description implies. The timeline argument is more complex. The biblical narrative places Abraham, the patriarch whose nephew Lot was saved from the destruction, in a period that has been variously estimated by scholars as the 20th, 19th, or 18th century BCE, with significant uncertainty in any of these estimates. The destruction of Tal el-Hammam, dated by the researchers to approximately 1650 BCE, falls within the range that some scholars assign to the period of Abraham and the patriarchs, though at the later end of the range. The difficulty is that biblical chronology is not precise in the way that archaeological stratigraphy is precise, and matching the two requires assumptions that can be made in more than one way. The argument from the narrative itself is perhaps the most compelling and the most difficult to evaluate with scholarly detachment, because it requires taking seriously the possibility that a 3,500-year-old oral tradition preserved a kernel of accurate information about a real catastrophic event. The Genesis account of the destruction of Sodom and Gomorrah contains specific physical details that are, on independent scientific grounds, consistent with what an airburst event would produce. Sulfur, or what the text calls brimstone, which refers to burning sulfur and which is a material that can be produced or carried by a comet or asteroid fragmentation event. Smoke rising like the smoke of a furnace, a phrase that evokes the billowing cloud of dust, ash, and combustion products that would follow an airburst and fire. The land, rendered permanently uninhabitable, the physical description matches, in ways that seem too specific to be coincidental, what the scientific reconstruction of the Tal el-Hammam event reveals. The detail of Lot's wife is particularly intriguing. She looks back at the destruction and is turned into a pillar of salt. Interpreted literally, this has no obvious physical mechanism, but interpreted as a memory of what happened to people who were too close to the blast when they fled, it acquires a different character. The shock wave of an airburst would have been lethal at distances far greater than the direct thermal effects. People attempting to flee from the city or from the plane might have been overtaken by the shock wave, or by the salt-laden aerosol cloud that the blast over the Dead Sea would have generated. A person killed by a supersonic pressure wave, blown down and covered in the mineral debris of the explosion, might indeed have looked, to a traumatized observer who survived by being further from the blast, like a figure made of salt. There is something in the Genesis narrative that is worth noting beyond the specific physical details. The account is not one of military conquest or natural disaster in the ordinary sense. It is an account of divine punishment, of cities destroyed for their sins. Whatever the theology of the story, the narrative form it takes is one of sudden, complete, and inexplicable destruction, something that struck without warning from the sky and left nothing. This is exactly what an airburst event would have appeared to be, to any surviving witnesses, or to any people within sight or hearing of the event, who were not directly affected by it. There is no preparing for an airburst. There is no gradual escalation that allows for warning or evacuation. There is the normal world, and then there is not, and the transition between them is measured in seconds. The memory of such an event, preserved in the oral tradition of people who were in the region at the time, would naturally take the form of divine action. What else, in the conceptual vocabulary of the ancient Near East, could explain such sudden and total destruction? The idea that something fell from the sky, that the very heavens rained destruction on a specific city, would be interpreted within the religious frameworks available to the ancient mind as the action of a deity who had decided to act. The text of Genesis does not merely say that the cities were destroyed. It says that Yahweh rained fire and brimstone from the sky. The physics of an airburst and the theology of divine punishment are not necessarily in conflict if the theology is understood as the ancient mind's interpretation of the physics. The counter-arguments to the identification of Tal el-Hammam with Sodom are genuine and should be taken seriously. The most fundamental is the problem of positive identification. We cannot confirm the identification of a biblical place without either an inscription naming the place or a precise enough match between the literary description and the archaeological reality to eliminate all other candidates. We do not have an inscription from Tal el-Hammam naming it Sodom. We do not even have inscriptions from the site that would allow us to establish what its Bronze Age inhabitants called it. The identification rests entirely on geographic and circumstantial arguments. Other sites have been proposed as Sodom over the decades. The site of Bab Ededra, at the southern end of the Dead Sea, was proposed as a candidate by some scholars, based on evidence of a destruction event in the early Bronze Age, though the chronology does not match well with the traditional dating of Abraham. Various other southern Dead Sea sites have been suggested. The specific character of the Tal el-Hammam identification, grounded in a scientifically documented catastrophic destruction event that matches the narrative in multiple specific details, makes it the most compelling candidate. But compellingness is not the same as certainty. The researchers are clear about this distinction in their paper. They do not claim to have proven that Tal el-Hammam is Sodom. They claim to have found evidence of a catastrophic airburst event at a site whose location and character match the biblical description of the cities of the plain, and to have identified correspondence between the physical evidence of the event and the narrative details of the Genesis account. This is a different and more modest claim, but it is a genuinely significant one. The broader scientific context of cosmic airburst events is important for understanding why the tall el-Hammam paper matters beyond the specific question of Sodom. The frequency of cosmic impact and airburst events is a subject of active scientific research, and the emerging picture is that such events are more common than was previously appreciated, even if events of the Tunguska scale remain rare by any ordinary human timescale. The 1908 Tunguska event remains the best documented cosmic airburst in history. On June 30th of that year, a fireball was observed across a wide area of Siberia, followed by an explosion that felled trees across an area of more than 2,000 square kilometers in the stony Tunguska River basin. The remote location of the event meant that no human lives were lost, but if it had occurred over a populated area of Europe or Asia, it would have been catastrophic. The energy released is estimated at between 10 and 15 megatons of TNT, making it the most powerful natural explosion in recorded human history. What Tunguska demonstrated, and what a century of subsequent research on the object and the event has confirmed, is that the explosion was not produced by a body that reached the ground. There is no Tunguska crater. The object, whether it was a stony asteroid or a dense fragment of a comet, was destroyed in the atmosphere, converted from a solid body to a plasma, and then to a dispersed cloud of hot gas and fine particles, releasing its energy in a single catastrophic moment of atmospheric detonation, an airburst. The same process that the researchers at Tall el-Hammam believe destroyed a Bronze Age city. The Younger Dryas cosmic impact hypothesis, which has been a subject of intense scientific debate since it was first formally proposed in 2007, suggests that a much larger airburst or impact event occurred approximately 12,900 years ago, at the beginning of the Younger Dryas cooling period that interrupted the warming trend at the end of the last ice age. The evidence assembled by proponents of this hypothesis includes a distinctive layer of platinum and other elements at the Younger Dryas boundary across multiple sites in North America, Europe, and other continents, the presence of nanodiamonds and other impact markers at the same boundary, and the roughly contemporaneous extinction of several large mammal species and the cultural discontinuity of the Clovis hunter-gatherer culture of North America. If the Younger Dryas impact hypothesis is correct, and the evidence for it has been growing more robust in recent years, it suggests that cosmic impact events have played a significant role in shaping human history not just once, but multiple times, at different scales and in different periods. A species of impact events that extends from the extinction of the dinosaurs 66 million years ago through a large impact event 12,900 years ago through the Tunguska event in 1908 is a pattern that suggests the Earth is regularly, if infrequently, struck by objects from space with consequences that range from global catastrophe to regional destruction. The Tall el-Hammam event, if the researchers' reconstruction is correct, falls into the middle of this spectrum, not a global extinction event, not a minor localized blast, but a regional catastrophe that destroyed a major city and rendered a fertile valley uninhabitable for centuries. Events of this scale, comparable to Tunguska in energy, but occurring over populated areas rather than remote wilderness, are the category of cosmic impact that poses the most immediate and specific threat to human civilization, and understanding their frequency and their effects is one of the practical motivations for taking the Tall el-Hammam research seriously. The 2013 Chelyabinsk event in Russia in which a much smaller body entered the atmosphere over a populated area and produced a shock wave that shattered windows and injured more than 1,000 people, demonstrated that even relatively minor airbursts can have significant human consequences. Chelyabinsk released energy estimated at between 400 and 500 kilotons of TNT, roughly 30 times the Hiroshima bomb, and yet it was far smaller than the Tunguska event and vastly smaller than whatever struck the Jordan Valley in 1650 BCE. The lesson of these events, taken together, is that the sky is not simply a backdrop to human history, but an active participant in it, occasionally delivering events that reshape the civilizations and the landscapes below. The specific mechanism of the Tol el-Hammam destruction, as reconstructed by the researchers, is worth following in detail, because the detail is where the science becomes vivid, where the abstract parameters of energy and temperature become the reality of a city's end. An object approximately the size of the Tunguska body, between 50 and 80 meters in diameter, enters the Earth's atmosphere at a steep angle from the northeast, moving at a velocity between 15 and 30 kilometers per second. As it descends through the atmosphere, air resistance heats it from the outside, and the pressure builds to the point where the object's internal strength cannot contain it. It breaks apart, not into a few large pieces, but into a cloud of fragments and vapor, releasing its kinetic energy in a fraction of a second. The fireball is the first physical consequence visible from the ground, a light far brighter than the sun, visible across hundreds of kilometers in every direction. Then comes the thermal pulse, a wave of heat radiating outward from the fireball at the speed of light, reaching the ground in the Jordan Valley, effectively simultaneously with the fireball itself. At the distance of Tol el-Hammam from the detonation point, the thermal pulse is intense enough to ignite any combustible material exposed to it, to melt surfaces of ceramic and brick, to kill any living thing in the open. The city's inhabitants, the pottery in the workshops, the grain in the storerooms, the animals in the pens, all of these are exposed simultaneously to a temperature pulse that, for a fraction of a second, approximates the conditions at the surface of a star. Then, slightly later, because sound travels much slower than light, comes the shock wave. The detonation has compressed the surrounding air into a high-pressure front moving outward at supersonic speed. When the shock wave hits Tol el-Hammam, it carries pressures that no mudbrick wall, no stone foundation, no architectural structure of any ancient period was built to withstand. The walls that have been standing for millennia do not fall gradually. They are pushed horizontally, the debris scattered outward from the blast center, the city's physical fabric converted in seconds from a standing urban landscape into a field of rubble. The shock wave continues outward from the city, diminishing with distance, but still violent enough to be felt and heard across the entire southern Levant, a thunderclap without precedent in the experience of any living person. The fires follow, ignited by the thermal pulse and fed by everything combustible in the city and on the plain. The smoke rises into the sky in a column that would have been visible from Bethel, from Jericho, from the hills of Judea to the west, from the highlands of Transjordan to the east. The biblical account says that Abraham, looking out from the hills near Hebron the morning after the event, saw the smoke rising from the plain like the smoke of a furnace. If the event happened, and if Abraham was where the narrative says he was, this is exactly what he would have seen. The scale of destruction extended beyond the city itself. The surrounding agricultural settlements, the farmsteads and small villages that depended on the city and that formed part of its economic and social ecosystem, were also destroyed or severely damaged. The Tol el-Hammam sits within a wider archaeological landscape that shows a broader pattern of abandonment in the same period, suggesting that the destruction of the city was accompanied by the disruption of the entire regional settlement system. The researchers' analysis of the event extends to consideration of its regional consequences. The salt layer deposited by the airburst shockwave over the Dead Sea area would have affected not just Tall el-Hammam, but the surrounding agricultural land, potentially rendering a substantial portion of the Kikar, the fertile plain that had supported the city and its satellite settlements for millennia, temporarily or permanently unsuitable for agriculture. A region stripped of its population by a catastrophic event, and then rendered agriculturally difficult by salt contamination, would indeed have appeared to subsequent generations as a cursed landscape, uninhabitable and avoided, exactly as the biblical tradition describes the fate of the plain of Sodom. There is something both scientifically remarkable and humanly profound about the correspondence between the detailed physical evidence from a Bronze Age archaeological site and a narrative that has been told and retold for approximately 3,500 years. Science and mythology are not, in general, in conversation with each other in a productive way. They address different questions through different methods and operate in different registers of knowledge. But occasionally, as in the work that revealed the historical reality behind the legend of Atlantis through the study of the Minoan civilization and the Thera eruption, or in the paleoclimatological research that has found corroboration for flood myths in the study of ancient sea level changes, the two converge in ways that are illuminating for both. The convergence in the case of Tal el-Hammam is particularly striking because it involves not a vague or general correspondence between a natural event and a mythological tradition, but a series of specific physical details in the narrative that match specific physical evidence in the archaeological record. Fire from the sky, airburst fireball, brimstone, sulfurous material from a cometary body, or evaporated salts from the Dead Sea raised by the shockwave. Smoke like a furnace, the dust and combustion cloud of a major explosion and fire. The land rendered uninhabitable, the salt deposit that makes agriculture difficult. The city never rebuilt, the 3 to 6 century abandonment that the archaeological record documents. None of this proves that the Genesis account is historical in every detail, or that the identification of Tal el-Hammam with Sodom is correct, or that the theological interpretation of the event in the biblical narrative is accurate. What it suggests is that a real event, a cosmic airburst of enormous destructive power, struck a real city in the Jordan Valley in approximately 1650 BCE, and that the memory of that event, transmitted through the oral tradition of the people of the region over centuries before it was written down in the form we know, preserved specific physical details of the destruction with a fidelity that science, 3,500 years later, can recognize. The researchers conclude their paper with a series of implications. The most immediately scientific is the evidence that airburst events capable of destroying cities have occurred within the historical period, within the period for which we have records, and that these events have likely shaped human settlement patterns and cultural history in ways that archaeology and history are only beginning to understand. The most archaeologically significant implication is that Tal el-Hammam warrants continued, systematic excavation, because much of the destruction layer remains unexplored, and the evidence it contains has the potential to refine and extend the picture that the current research has drawn. The ground at Tal el-Hammam still holds what it has held for nearly 4,000 years. The destruction layer, 1.5 meters of compacted debris from a city's end, extends across the tell beneath the later accumulations. Within it, preserved by the same catastrophic event that killed the city's inhabitants, are the physical remains of a Middle Bronze Age civilization at the moment of its destruction, the pottery that was fired in the workshops, the tools that were used in the trades, the personal objects of the 50,000 people who died in seconds when something fell from the sky. 50,000 people. In the conventions of modern disaster discourse, 50,000 people is a number that evokes global attention and sustained humanitarian response. In the conventions of ancient history, it is a number that represents an entire urban civilization, the concentrated intellectual, economic, and social capital of a region that had been developing and refining its culture for 2,500 years. The potters who made the vessels, whose outer surfaces the airburst melted, had learned their craft from teachers who had learned it from teachers, across generations, stretching back before the Bronze Age. The scribes who may have maintained the city's records, the priests who maintained its temples, the merchants who connected it to the trade networks of the ancient Near East, all of them gone in seconds. The memory of that loss was carried forward. It was carried by whatever survivors there were, people who had been far enough from the blast to survive, people who had been outside the city when it happened, people who saw the smoke and felt the shock wave, and found, when they went to look, that the city and the plain were gone. It was carried through the following centuries, through the 300 or 600 years of abandonment that the archaeological record documents, through the gradual return of human settlement to the region, through the cultural transformations that the Bronze Age collapse and the Iron Age emergence brought to the entire Levant. And eventually it was written down in the form of a story about divine punishment and human wickedness and the destruction of cities by fire from heaven, a story that has been told and retold for 3,500 years and that is still being told. The ground is there. The debris is still in it. The evidence is still accumulating, season by excavation season, as the archaeological team returns to the tell and extends its understanding of what was found there. The paper published in September 2021 is not the end of the investigation. It is one chapter of it, a chapter that has established the outlines of what happened with enough precision to make the story legible, while leaving most of the details yet to be recovered from the soil. 50,000 people lived in that city. Something fell from the sky. The city died in seconds. And for 3,500 years, people have been telling a story about it, without knowing it was a story about something that really happened, about fire from heaven and a city turned to ash and a fertile plain turned to salt. The science and the scripture are pointing at the same place. They are pointing at el-Hammam and at the sky above it, and at whatever came out of that sky one afternoon, approximately 3,600 years ago, and ended the world for everyone who lived there. The tell is still there. The destruction layer is still there. And somewhere above the Jordan Valley, invisible in the daylight, but present in the long catalogue of human experience of catastrophe, the memory of a fireball that was briefly hotter than the sun lingers in a story about God raining fire on a wicked city, a story whose specific physical details match, with striking precision, what the science of cosmic airbursts predicts for an event of this scale, in this place, at this time. The ground is waiting, the sky remembers nothing, and the human memory, which preserves what happened even when it cannot understand what happened, turned physics into theology and kept the story alive until the archaeologists came to find out what it was really about. It was about this, a city, a morning, something in the sky, and then nothing where everything had been. The reaction to the paper when it was published was substantial, and the range of responses it received illuminates something important about how science and culture interact in the specific domain where archaeological evidence meets religious tradition. The paper was published in a peer-reviewed, internationally recognized scientific journal, reviewed by specialists in the relevant fields, and it passed that review on the merits of its evidence and methodology. This is the process by which scientific claims are evaluated, and the paper's publication in Scientific Reports represents a significant endorsement of the quality and rigor of the work. Among scientists who study cosmic impact events, the airburst interpretation of the tall el-Hammam evidence was received as a credible hypothesis, warranting further investigation. The specific evidence types, the spherules, the shocked quartz, the iridium and platinum anomalies, the vitrified mudbricks, are the same types of evidence that have been used to identify other airburst events and impact sites, and their presence together at Tall el-Hammam in a Middle Bronze Age destruction layer is not simply suggestive, but constitutes a substantive scientific case. The researchers are careful to use the language of hypothesis and evidence rather than proof, which is appropriate given the inherent uncertainties of reconstructing a specific event from archaeological evidence, but the direction of the evidence is clear. Among archaeologists and biblical scholars, the reaction was more mixed. Some welcomed the paper as a significant contribution to the understanding of the ancient Levant and as a demonstration of the value of interdisciplinary approaches that combine traditional archaeological fieldwork with modern geochemical and materials science analysis. Others expressed reservations about the identification of Tal el-Hammam with Sodom, reservations that are appropriate given the evidentiary standards required for archaeological identification of sites mentioned in ancient texts. The biblical scholarship community's response was divided along lines that partly reflect methodological commitments and partly reflect the specific sensitivities that attend any research that touches on the historical basis of scriptural texts. Scholars who approach the Hebrew Bible as a historical source, potentially containing memory of real events, though filtered through theological interpretation and literary convention, were interested in the correspondence between the physical evidence and the narrative details. Scholars who approach the text primarily as a theological and literary document, whose relationship to historical events is complex and not necessarily direct, were more cautious about the correspondence. The genuinely important methodological point, which the researchers acknowledge in their paper, is that establishing a physical event that corresponds to a biblical narrative is not the same as establishing that the biblical narrative is historically accurate in all its details. The airburst at Tal el-Hammam, if it occurred as the researchers describe, was a physical event, not a divine punishment. It was not selective in the way the narrative implies, destroying Sodom, but sparing the nearby city of Zoar and the people who fled in time. It was not preceded by the divine visitation and negotiation with Abraham that Genesis describes. These narrative elements are not explained by the airburst hypothesis, nor should they be. They are theological and literary framings of an event that, in the world of the narrative, has theological and literary significance. What the airburst hypothesis does explain, which is the more modest and more defensible claim, is that a real catastrophic event occurred in the southern Jordan Valley in approximately the right period, with physical characteristics that match specific details of the biblical narrative, at a site whose geographic position matches the description of the cities of the plain. This is sufficient to suggest that the Genesis account of Sodom and Gomorrah may be, at its core, a preserved memory of a real event, shaped by the theological and literary conventions of its tradition into the form in which we now have it. The question of how oral traditions preserve memories of real events is itself a significant area of research in anthropology and folklore studies. The capacity of oral traditions to preserve accurate information over long periods varies enormously depending on the nature of the information, the strength of the transmission conventions, the social functions the tradition serves, and the degree to which the tradition is subject to change over time. Events that are dramatic, unique, and directly experienced by many people tend to be well preserved in oral tradition, at least in their broad outlines. The destruction of a major city by fire from the sky, an event affecting tens of thousands of people and visible across a wide geographic area, would be exactly the kind of event that oral tradition would preserve with some accuracy, at least in its broad outlines. The specific physical details that the Genesis account preserves, fire from the sky, sulfur, smoke like a furnace, the land never rebuilt, correspond to broad outlines of what an airburst event would produce, rather than to the fine details that would require precise scientific understanding to describe accurately. This is exactly the pattern you would expect from an oral tradition based on eyewitness experience and subsequent observation, the broad outlines of what was experienced, translated into the language and conceptual categories of the people who experienced it, are preserved, while the details beyond direct experience, the specific mechanism, the extraterrestrial origin, the precise magnitude, are not available to the tradition and are not described. The Genesis narrative does not describe an asteroid or comet. It does not describe an airburst in atmospheric terms. It describes divine action, which is the framework available to the ancient minds that transmitted the tradition. But within that theological framework, it preserves specific physical details of a catastrophic event, fire from the sky, a specific material called brimstone, smoke rising from a specific location, the destruction of specific places, the transformation of a specific landscape, that are consistent with what science finds at el-Hammam. This is remarkable, and it is the kind of correspondence that rewards careful attention from both scientific and humanistic perspectives. The material evidence from el-Hammam also speaks to the experience of the event in ways that the biblical narrative does not. The pottery in the workshops was in use at the moment of the event. The grain stores were full, as they would be in a productive agricultural city of this size. The personal objects, the tools and ornaments and household goods that are the material vocabulary of daily life in any period, were in the places where they were being used or stored. The city was functioning normally, without any sign of preparation for the disaster that was about to occur. There was no evacuation, no stockpiling of supplies in anticipation of siege, no evidence of the social disruption that typically precedes a military conquest or a prolonged environmental crisis. This is what an airburst does. It does not give warning. It does not allow for preparation. It arrives in the sky as a point of light, and within seconds, it has converted a functioning city into ash and rubble. The people of el-Hammam had no more warning than the people of Hiroshima and Nagasaki when they looked up and saw the B-29s that delivered a weapon that also, in its own way, derived its destructive power from physics that had not previously been weaponized in human history. The analogy is imperfect in important ways, but the scale of sudden, total destruction is comparable. The skeletons that have been found in the destruction layer at el-Hammam tell part of the human story of the event. Disarticulated bones, scattered and displaced by the violence of the blast and subsequent collapse of structures, show evidence of the extreme heat to which the bodies were exposed. The arrangement of the bones is not the arrangement of people who died in fires or building collapses, where bodies tend to be found in specific positions that reflect how they fell and where the debris landed on them. The bones at el-Hammam were moved, blown about by the force of the shock wave, scattered in ways that reflect the chaotic physics of a major explosive event, rather than the more ordered physics of structural collapse or fire. The human remains in the destruction layer are partial. Much of what should be there is missing. This is consistent with the temperatures implied by the vitrified mudbricks and the melted pottery surfaces. At the temperatures involved in a major airburst, soft tissues are rapidly destroyed, and the bones themselves can be significantly degraded or even vaporized at the closest ranges to the detonation. The bones that survive do so because they were somewhat sheltered, perhaps in building interiors where the thermal pulse was partially blocked, or because they were at sufficient distance from the center of the blast that the temperatures, though devastating, were not the extreme temperatures of the detonation center. The pattern of destruction across the site also reflects the specific physics of an airburst. Objects closer to the detonation point show more extreme heat damage. Objects further away show less. This gradient of damage is consistent with a point source of heat and pressure, which is what an airburst produces, and is inconsistent with the kinds of destruction that fire or military action typically produce, where the damage tends to be more uniform or follows the pattern of building structure rather than distance from a single point. The researchers spent years accumulating and analyzing this evidence before publishing, subjecting their samples to multiple independent analyses to verify the results and rule out alternative explanations. The vitrified mudbricks were analyzed by specialists in materials science who have no particular stake in the interpretation of a biblical site, and who brought to the work the same methodology they would bring to any unusual material: characterization of the elemental and mineral composition, analysis of the thermal history implied by the observed microstructure, and comparison with known reference materials from other impact and airburst sites. The spherules were analyzed by specialists in cosmic impact geology who have extensive experience with the characterization of such particles from other known impact sites. The platinum and iridium measurements were taken by geochemists using techniques capable of detecting the trace concentrations involved, with appropriate controls for contamination and background. The shocked quartz was examined by mineralogists who specialize in high-pressure mineral deformation. Each line of evidence was subjected to the appropriate specialist scrutiny, and each converged on the same conclusion: the destruction layer at el-Hammam preserves evidence of a cosmic airburst event. The salt layer deserves further attention because its presence and its connection to the biblical narrative are not straightforward. The Dead Sea region is rich in salt, and salt deposits are found throughout the geological record of the Jordan Valley at various depths. The researchers were careful to distinguish the salt associated with the destruction layer from salt in other parts of the stratigraphic sequence, and their argument is that the specific horizon of salt found above the destruction layer is not simply a feature of the natural salt-rich environment, but represents a deposition event associated with the destruction. The mechanism they propose, in which the airburst shockwave struck the surface of the Dead Sea and drove a salt aerosol inland that then deposited over the surrounding landscape, is physically plausible. The Dead Sea's surface concentration of salt and other dissolved minerals is extraordinarily high, and a supersonic shockwave striking that surface would create an aerosol of very high salinity. The deposition of this aerosol over the agricultural lands of the Kikar would have added significant quantities of salt to soils that were already at the edge of what crops can tolerate, given the natural saltiness of the Jordan Valley environment. The agricultural consequences of salt loading in the Jordan Valley would have been severe and potentially long-lasting. Salt accumulation in soil is a serious agricultural problem that modern farmers deal with through irrigation management and drainage, but which Bronze Age farmers had limited capacity to address. A sudden salt loading event of the scale that an airburst shockwave over the Dead Sea might produce could have made the previously fertile Kikar unsuitable for agriculture for years or decades, compounding the immediate destruction of the city with a medium-term agricultural crisis that would have prevented or delayed recolonization. This medium-term consequence would have been experienced as a transformed landscape, a place where the soil no longer produced crops, where the famous fertility of the region had been replaced by barrenness. The transformation of a fertile plain into a barren landscape is a powerful image, and it is an image that the biblical tradition preserves in the description of the fate of the plain of Sodom. What Genesis describes as divine punishment, the permanent transformation of a fertile region into a wasteland, corresponds to what the archaeology and geochemistry suggest was a medium-term agricultural consequence of the salt loading from the airburst shockwave. The recovery of the landscape over the following centuries is also consistent with what would be expected from a salt loading event. Salt, unlike some other soil contaminants, can be leached over time by rainfall, gradually reducing its concentration to levels that allow agricultural activity to resume. The eventual return of human settlement to the el-Hammam area after the 3 to 6 century hiatus documented in the archaeological record may reflect the gradual recovery of the soil from the salt loading rather than simply the passage of enough time for people to forget the destruction. The city that eventually grew up on the site of el-Hammam after the abandonment period was a different city, not the metropolis of the Middle Bronze Age, but a smaller, less ambitious settlement. The great walls and towers, the elaborate administrative and religious infrastructure of a major Bronze Age city were not rebuilt. The people who returned were returning to a landscape that had been dramatically impoverished, not just by the physical destruction of the city, but by the disruption of the agricultural and social systems that had sustained it. Rebuilding a major urban center is not simply a matter of reconstructing the physical fabric. It requires the reconstruction of the economic, social, and political systems that the city expressed, and those systems had been destroyed as completely as the mudbrick walls. The paper published in Scientific Reports in 2021 is, the researchers make clear, a beginning rather than an end. The excavation of el-Hammam has been ongoing for nearly 2 decades, and the destruction layer that is the subject of the paper covers an area of the tell that has been only partially investigated. Much of the tell remains unexcavated, and within the destruction layer itself, there is far more evidence than has yet been systematically studied. Future excavation seasons will extend the understanding of the event and its consequences, potentially refining the estimates of the event's magnitude and the area it affected, and potentially recovering evidence that speaks more directly to the question of identification. The question of identification, of whether el-Hammam is genuinely the biblical Sodom, is one that the researchers are appropriately reluctant to press beyond what the evidence supports. What they can say with confidence is that a major city in the location that Genesis describes for the cities of the plain was destroyed in approximately the period that the biblical tradition associates with Abraham by an event of the type and scale that the narrative describes, in terms of fire from the sky and total destruction and the subsequent transformation of the landscape. Whether the people who told this story knew that the city they were describing was called Sodom, or whether Sodom was the name that subsequent tradition assigned to a destroyed city that the tradition remembered, is a question that may not be answerable from the archaeological evidence alone. The physical reality of the event, however, is not in doubt. Something fell from the sky above the Jordan Valley in approximately 1650 BCE. It fell with sufficient energy to melt pottery and vitrify mudbricks and deposit spherules and iridium anomalies and shocked quartz across the destruction layer of a major Bronze Age city. The city died in seconds, with its 50,000 inhabitants, and the plain it had dominated for 2,500 years was salted and abandoned for centuries. The memory of this event, preserved in a narrative tradition that has survived 3,500 years and has been transmitted in multiple languages across multiple continents, tells of fire from heaven and a city consumed and a fertile plain transformed into a wasteland. The memory is imperfect, shaped by the theological and literary conventions of the tradition that carried it, no longer simply a physical account of a physical event, but a story embedded in a larger story about divine justice and human wickedness. But within the imperfect memory, the physical details are there: fire from the sky, sulfur, smoke like a furnace, salt, a city never rebuilt. The ground at el-Hammam still holds the evidence of that morning. The destruction layer is still there, beneath the surface of the tell, preserved by the same event that created it. The pottery that was melted from the outside in, the mudbricks that were converted to glass, the spherules that formed when something fell and exploded, the iridium from the extraterrestrial body that did not survive its fall, all of it is still there, waiting for the next excavation season, waiting for the next analysis, waiting for the gradual accumulation of scientific understanding that will eventually resolve the questions that the current research has raised. In the Jordan Valley, the hills are old, and the soil is deep, and the sky above is the same sky that was there in 1650 BCE, when something fell out of it. The people who lived beneath that sky, on that morning, did not know what was coming. They could not have known. They were going about their lives in the city they had inherited from their parents and that they expected to pass on to their children, in the most fertile plain in the southern Levant, in a landscape that had supported their ancestors for 2,500 years. And then the sky gave them no more time than it takes to fall. The story survived. The city is waiting to be fully understood, and the science, patient and rigorous, and accumulating its evidence season by season, is slowly reading the record that the event left in the soil. Translating the language of shock waves and thermal pulses and elemental anomalies into the story of what happened, and what it was like, and who was there, and why the memory of it has lasted for 3,500 years, in a story told by people who preserved what they knew of a morning when the sky fell on a city, and the world ended for everyone who lived there. The interdisciplinary character of the research team that produced the 2020-21 paper is worth examining because it reflects both the complexity of the question and the growing sophistication of archaeological science. The team of 21 researchers included specialists from an unusually wide range of disciplines: archaeologists with direct field experience at el-Hammam, geologists expert in sedimentary analysis, geochemists who specialize in trace element analysis, materials scientists who study the behavior of minerals under extreme conditions, specialists in cosmic impact science who have studied other airburst and impact sites around the world, and biblical scholars who contributed their expertise in the literary and historical context of the Genesis narrative. This interdisciplinary collaboration is a feature of the best contemporary archaeological science, which has moved beyond the traditional model of archaeologists working alone or with a small team to embrace the analytical power of the natural sciences as applied to archaeological materials. The pottery analysis, the geochemical measurements, the mineralogical examination of shocked quartz and spherules, all of these require specialist expertise that goes well beyond what any individual archaeologist can be expected to possess. The value of the 2021 paper derives in large part from the fact that each line of evidence was evaluated by people with the appropriate expertise to assess its significance, rather than by generalists attempting to reach outside their competence. The publication of such a paper is also a reminder that archaeology is a science in the full sense, subject to the same standards of evidence and peer review that apply to any scientific discipline. The claims made in the paper are extraordinary, and the evidence marshaled to support them is correspondingly substantial. This is not popular science speculation or alternative archaeology of the kind that circulates on the internet and in bookshops. It is a peer-reviewed scientific paper that has gone through the scrutiny of the academic refereeing process, and that can be evaluated by anyone with the scientific background to understand the methods and the evidence. The evidence from Tall el-Hammam does not stand alone in the broader landscape of evidence for cosmic impact events in the ancient period. The Younger Dryas impact hypothesis, which proposes that a significant cosmic impact occurred approximately 12,900 years ago at the end of the last ice age, has accumulated a substantial body of supporting evidence in the years since it was formally proposed, including the identification of the platinum anomaly that is the most diagnostic indicator of the event at sites across multiple continents. The evidence for the Younger Dryas impact event, while still debated in some of its details, represents a convergent picture from multiple independent lines of analysis that points toward a real cosmic event with significant consequences for the Earth's climate and for human populations. If the Younger Dryas impact hypothesis is correct, it establishes that cosmic impact events capable of affecting human civilization have occurred more than once in the human period, at intervals that are long by human experience but short by geological time. The pattern of the Younger Dryas event, approximately 12,900 years ago, the Tall el-Hammam event, approximately 3,600 years ago, and the Tunguska event, 116 years ago, suggests that airbursts comparable to or larger than Tunguska occur roughly every few thousand years. This is a frequency that is consistent with the known population of near-Earth objects, the asteroids and comet fragments whose orbits bring them close enough to Earth that they can interact with the atmosphere, and it suggests that the history of human civilization on a timescale of thousands of years is likely to include multiple such events. The implications for the interpretation of ancient history and ancient religious traditions are significant. If cosmic impact events have occurred at intervals of a few thousand years throughout the period of human civilization, the memories of those events preserved in the oral traditions of ancient peoples are likely to be part of the historical record of the events. The flood myths, found in cultures across the world, some of which have been connected by scholars to the sea level rise at the end of the last ice age, may also include elements derived from the memory of specific catastrophic events, including cosmic impacts. The traditions of fire from the sky, of sudden catastrophic destruction without warning, of landscapes transformed by events that seem to come from the heavens, found in multiple ancient traditions, may be preserving the memory of real events of the type that the Tall el-Hammam evidence documents. This is not to say that every ancient story of celestial catastrophe corresponds to a real impact event, or that the religious and mythological frameworks in which such memories are preserved should be stripped of their theological content and reduced to physical events. It is to say that the relationship between natural catastrophe and religious tradition is more complex and more interesting than either a purely naturalistic reading, which dismisses the theological content as primitive error, or a purely theological reading, which denies the relevance of the physical events, can capture. Human communities that experience catastrophic events do not simply record them as scientific observations. They interpret them within the frameworks of meaning that their traditions provide, and those frameworks shape the form in which the memory is preserved and transmitted. The Genesis account of Sodom and Gomorrah is a story about divine justice, about the consequences of wickedness, about the limits of divine tolerance and the nature of divine intervention in human affairs. These are theological themes, and the story serves theological purposes in the context of the Hebrew Bible's larger narrative. But within the theological framing, specific physical details of a real event appear to be preserved, details that are consistent with what the science of cosmic airbursts predicts for an event of this scale in this place. The theological meaning that the tradition has assigned to the event is not negated by the physical reality of the event. It is the tradition's interpretation of that reality, its attempt to make sense of something that seemed to come from beyond the world of ordinary human experience, because it did come from beyond the world of ordinary human experience. The people of Tal el-Hammam did not cause the airburst. Whatever the theological tradition says about the wickedness of Sodom, the physics of a cosmic airburst is indifferent to the moral status of the population below it. 50,000 people died, not because of their choices or their behavior, but because of the orbital mechanics that brought an extraterrestrial body into the Earth's atmosphere above their city on a specific afternoon in approximately 1650 BCE. The theological interpretation, which reads the event as divine punishment, is the ancient mind's attempt to make sense of an event that seemed to require a purposeful agent, something that explained not just how the cities were destroyed, but why. This interpretive move from physical event to theological explanation is one of the most fundamental acts of human meaning-making, and it is not confined to the ancient world. The question of why, applied to catastrophic events that kill large numbers of innocent people, is one that human communities continue to grapple with, and the answers they arrive at reflect the theological and philosophical frameworks of their specific traditions. The ancient Levant's response to the destruction of the cities of the plain was to interpret it as divine judgment. That interpretation shaped the story that has been told for 3,500 years, and that has been transmitted across continents and languages and generations to the present day. The science of the airburst is not a refutation of the story's meaning. It is, in a strange way, a confirmation of the story's reality, a demonstration that something extraordinary really did happen in the southern Jordan Valley approximately 3,600 years ago, something that deserved the status of a story worth telling and a memory worth preserving. The specific physical reality that the science reveals, a cosmic body fragmenting above the Jordan Valley and delivering energy equivalent to 1,000 atomic bombs to a city of 50,000 people, is as extraordinary as anything in the Genesis narrative, more extraordinary in some respects, because it is true and verifiable and documented in the evidence that the Earth has been holding for nearly 4,000 years. 50,000 people, a morning in approximately 1650 BCE, something falling from the sky, a city gone in seconds, and then the centuries of silence, the empty tell, the salt-laden soil, the abandoned plain, and then the slow return, the small settlements, the diminished city on the ruins of the great one. And then the story, passed from mouth to ear across the generations, shaped by the theological imagination of the people who carried it, until it reached the form in which we have it: fire and brimstone from the sky, a city consumed, a plain salted, a story about divine justice and human wickedness that has been told and retold for 3,500 years. The Tel Atol el-Hammam is still there, rising above the Jordan Valley floor. The destruction layer is still within it, still holding the vitrified mudbricks and the melted pottery and the shocked quartz and the spherules and the iridium and the disarticulated bones of the people who lived there. The Earth has been holding this evidence for nearly 4,000 years, more patiently than any archive, more faithfully than any tradition, simply preserving what was deposited in a single afternoon when the sky fell and the world ended for everyone who was there to see it. The excavation continues. The science accumulates. The questions refine. And somewhere beneath the surface of the tell, in the next layer yet to be uncovered, in the debris of the next square meter yet to be carefully excavated, there is more evidence of what happened on that afternoon, more information about the event and the city and the people who lived there, waiting for the patient work of the researchers who will read it in the language of mineral structure and elemental composition and stratigraphic context. The sky has no memory. The earth has all of it. And from the earth, slowly, season by season, the story of what happened in the Jordan Valley 3,600 years ago is being recovered, not as a legend or a myth or a theological narrative, but as a physical record of a real event that killed real people and that preserved its own evidence in the soil for long enough to be found by the science that can read it. This is what happened to Sodom, or to whatever city stood at Tal el-Hammam and whose memory became the story we know. This is what the evidence says. And the evidence is in the ground, and the ground is still there, and the science has only just begun to understand what it holds. There is one more dimension of the Tal el-Hammam story that deserves attention before this account closes, and it is the dimension that connects the specific scientific findings of the 2021 paper to the broader history of how human civilization processes catastrophic loss. The destruction of a city of 50,000 people is not simply a geological event. It is a human catastrophe of the first order, and its aftermath is a human story as much as a physical one. What happens to the survivors of a catastrophic event when they are the lucky ones who were outside the city or in positions of relative shelter? What does the human mind do with the sight of a city gone in seconds, with the complete and sudden loss of everything and everyone that the community was? The psychological and social processes that follow such events are, in the modern context, the subject of extensive study in trauma psychology, disaster response, and community resilience. In the ancient context, they were managed through the resources available to ancient communities, kinship networks, religious frameworks, oral tradition, and the collective meaning-making that narrative provides. The survivors of the Tal el-Hammam airburst would have had no framework for understanding what they had witnessed. They would have known that something fell from the sky. They would have known that the city was gone. They would have known that the plain was inhospitable, the soil wrong, the familiar landscape transformed into something dangerous and alien. And they would have needed to make sense of this, to explain it to themselves, and to their children, and to anyone who would hear them, in the only terms available to them, the theological and mythological categories of the ancient Near Eastern world in which they lived. The story they told would not have been a scientific account. It would have been what it became, a narrative of divine action, of a God who looked at the wickedness of a city and decided to destroy it, of fire and brimstone from the sky, of a transformation of a fertile plain into a wasteland. This is the story that Genesis preserves, and it is the story that has been told for 3,500 years. It is not the scientific story of an airburst, but it is the humanly true story of people who survived the airburst and who needed to understand it in the only way they could. The scientific investigation of Tal el-Hammam does not diminish this human story. It enriches it. It adds to the theological and narrative account of Sodom and Gomorrah a physical reality that gives the story a different kind of weight, the weight not just of theological meaning, but of actual event, of things that happen to actual people in an actual place. The 50,000 who died at Tal el-Hammam become, through the science, more real and more present, not reduced to characters in a divine drama, but restored to their full humanity as people who were going about their lives when something from the sky ended those lives in seconds. This is the final thing to say about Tall el-Hammam and about the story that may have grown from it. The science does not answer the theological questions. It does not tell us whether God is real, or whether the people of Sodom were wicked, or whether the destruction was just. These are questions that are outside the domain of science, questions that belong to theology and philosophy and the individual human conscience. What the science tells us is that the event happened, that people died, that the city was real, and the destruction was real, and the memory of it was real enough to be preserved in a story for 3,600 years. The ground at Tall el-Hammam holds the evidence of the people who died there. Their pottery is there. Their buildings are there, in vitrified fragments. Their bones are there, scattered by the violence of the shockwave. Their city is there, in the destruction layer that the excavation has begun to reveal. And in the soil above the destruction layer, in the centuries of silence that followed the event, there is the physical record of a landscape that tried to recover and eventually did, slowly, not fully, not to what it had been, but enough for people to return and begin again. The story of Sodom and Gomorrah is, among other things, a story about beginning again. It is a story about Lot, the survivor, who fled with his daughters and established himself in the hill country and began again, and from whose descendants the tradition traces the origins of the nations of Moab and Ammon. Whatever the theological dimensions of this genealogical claim, the narrative structure is one of survival and continuation, of a world that was catastrophically destroyed, but that did not remain destroyed, of people who carried the memory of the catastrophe and from whom more people descended. This is a deeply human story, and it corresponds to what archaeology tells us about the aftermath of the Tall el-Hammam destruction. People did survive. The region was not permanently uninhabited. After the centuries of abandonment, people returned. They built smaller structures on the ruins of the great city. They began again. The story went on, even if the specific city of Tall el-Hammam never recovered its former scale and sophistication. The memory of what happened on that afternoon went on too, encoded in a narrative tradition that would eventually be written down and that would survive, in written form, through the millennia to the present day. The memory persisted not because it was preserved in stone or in pottery or in the soil of the tell, though the evidence in the soil is what science has now recovered. It persisted because it was too important to forget, too large and too terrible and too strange to allow to pass from human memory, and so it was told and retold and shaped and transmitted until it became the story we know. The tell is in Jordan, in the Jordan Valley, northeast of the Dead Sea, on the edge of what was once the most fertile plain in the southern Levant. The hill rises above the surrounding landscape, the accumulated evidence of 2,500 years of habitation below, the destruction layer about a third of the way down from the surface, the pre-destruction city below that, and the earliest occupation at the bottom, the Chalcolithic farmers who started the whole long history of this place before any of what we think of as the Bronze Age began. The excavation goes on, the science accumulates, and somewhere in the destruction layer, in the next meter of soil that has not yet been reached, there is more evidence of what happened on that morning, more testimony from the city that died in seconds when something fell from the sky. The sky above the Jordan Valley is the same sky. The valley is the same valley, and the evidence of what happened there 3,600 years ago is in the ground, waiting for the next excavation season, waiting for the next analysis, waiting for the next question that the evidence can answer. The story will continue to be told. The evidence will continue to be found. And the connection between the two, between the ancient narrative and the physical reality it may be preserving, will continue to illuminate both, enriching the scientific understanding of a catastrophic event with the human context of the people who experienced it and were destroyed by it, and enriching the story's meaning with the physical reality of 50,000 people who lived and died in a city that vanished in seconds beneath a sky that had, for a fraction of a second, become hotter than the sun. They lived. Something fell. The ground remembers. And the story, which may have begun with those who survived telling those who had not been there what it was like when the sky fell, is still being told.